Okay, matrix, let's have a look at Theorem 1 converse. What it says if a line cuts two sides of a triangle proportionally, then that line is parallel to the third side. Let's see what we mean. What it says, look, if you've got a triangle, and in this triangle you can prove that AD over DB is, in other words, AD over dB is AE over EC is equal to AE over EC. If that's true, then what we can conclude is that the line DE is parallel to BC. And this is what we call the converse of Theorem 1. Okay, let's have a look at an example quickly. What we want to do in this example, if you look at this information, we want to prove that DE is parallel to AB. Now we've got CD and we've got DA, we've got CE and EB. So if we create ratios, let's see what happens. Now watch this. If you take CD divided by DA, what do we get? Well, let's have a look here. CD is 14 centimeters, DA is 6 centimeters, and the centimeters cancel. 14 divided by 2 is 7, 6 divided by 2 is 3. In other words, you've got a ratio of 7 parts to 3 parts there. Okay, now what about the ratio CE to EB? Let's have a look at that. Okay, that's CE is 21 to EB is 9, so it's 21 over 9. So let's have a look here. 21 centimeters over 9 centimeters. The centimeters cancel, and look at that. Divide 21 by 3, you get 7. Divide 9 by 3, you get 3. The ratios are exactly the same. So this is also 7 parts to 3 parts. And obviously we would use different letters there to indicate the actual lengths there. But now watch this. We can therefore say that CD over DA is equal to CE over EB. And because of that, we then know that DE is parallel to AB, and that means what we can say is we can use the reason that says line divides the sides of the triangle, and we use the word proportionally. Okay, there it is. So if CD over DA is CE over EB, which they're both 7 over 3, then DE is parallel to AB. Okay, now let's have a look at another theorem which is referred to as the midpoint theorem. It's still like Theorem 1, but what it says, you'll notice here you've got AD is equal to DB and AE is equal to EC. Now the midpoint theorem says, now watch this carefully, there are many variations of this. If AD is equal to DB, so in other words, if AD is equal to DB and at the same time DE is parallel to BC, so we've got those two. So AD is equal to DB and DE is parallel to BC. We can conclude, then we can say that AE is equal to EC. This is the midpoint theorem. Or what you can say is, you could also say if AD equals DB, so that side equals this, and at the same time AE is EC. If you've got that, you can then say straight away that DE is parallel to BC. That's another version of the midpoint theorem. And by the way, if you look at BC, BC is actually 2DE. So in other words, if DE is X, BC is double that. Or we can say that DE is a half of BC. Okay, that DE is a half. That's the relationship in the midpoint theorem. Okay, now let's explore an example that involves the midpoint theorem. Have a look here. PQRS is a kite. Okay, so if it's a kite, we've got QP, this whole side is equal to that whole side, and this whole side is equal to that whole side. But what they're saying is they're saying too that if you look at this, A and B are the midpoints of PQ and PS. So if they're midpoints, if A is a midpoint, that equals that, and B is the midpoint of PS, those are equal there. Now notice from the midpoint theorem, if PA is AQ and PB is BS, you can immediately conclude that these two lines are parallel in that triangle PQS. Okay, now let's have a look what else they say. They also say that QD is DR, so we've got QD is equal to DR, and SC is equal to CR, so those are equal. SC is equal to CR, we've given that. Now we want to prove that ABCD is a parallelogram. Well, let's have a look. Let's start off, if we can have a look at this carefully. Look at the bottom triangle. You've got QD is DR and SC is DR. So from the midpoint theorem, those lines are parallel too, which of course means that all three lines are parallel, which proves that AB is parallel to DC, and then we can do it in other triangles. So let's do this slowly. Let's start off with triangle PQS at the top. Okay, so we've got here in triangle PQS. Okay, in triangle PQS there, which is the top triangle. What do we know? We know that PA is AQ and PB is equal to BS. Let's look at that in the diagram. In the top triangle PQS there, we've got PA is AQ and PB is BS. And therefore we can say that AB is parallel to QS. So therefore AB is parallel to QS from the midpoint theorem. Okay, have a look at that again. We've got PA is equal to AQ. This piece is equal to that, and PB is BS, and that automatically means that that AB is parallel to QS. Now go to the bottom triangle. If you look at the bottom triangle, is going to be QSR. Now what do we know? QD is DR, so QD is DR, and SC is equal to CR, which means therefore that that line is parallel to this one. Okay, which in turn is parallel to that. Okay, so let's set that out. QD, so we can say what's the triangle? In triangle QSR. Okay, what's going to happen in QSR? QSR here. We've got QD is DR. QD is DR. Okay, QD is DR, and SC is CR. SC is CR. And what does that tell us therefore? It tells us therefore that if you look at that, we've got DC is parallel to QS in this bottom triangle. QD is equal to DR, SC is CR, so therefore DC is parallel to QS. Okay, so therefore DC is parallel to QS, and once again that's the midpoint theorem. Okay, cool. Then we can say that therefore that AB must be parallel to DC. Okay, because if you think about it carefully, all those three lines are parallel. Now I'm going to go, now if I look at this, I want to prove now that AD is parallel to BC. Now I'm going to do, if you look at triangle PQR, what do you know? Let's write that down. So we've got here in triangle PQR, what do we know in triangle PQR? Okay, in PQR we've got, we're going to do a different color here. We've got PA is equal to AQ and QD is equal to DR. So automatically that is parallel to this side here. Okay, so those are parallel. Okay, so let's go PA to AQ. PA is equal to AQ. If you look at PQR, and also QD is equal to DR. See that there? QD is equal to DR. Okay, so therefore AD is parallel to PR. And therefore AD is parallel to PR. Midpoint theorem. Okay, AD is parallel. And then you can also go to triangle PSR. Let's have a look at PSR. Where's that? If we go up here, PSR, if you look at this triangle here, we've got in this triangle PSR here, we've got, if you look at that, we've got PB is equal to BS, so PB is BS, and SQ or SC is equal to CR. So and therefore BC is parallel to PR, and therefore if they're parallel, all three lines are parallel. So in other words, AD is parallel to BC. So let's just conclude that quickly. What do we know in PSR? Let's just go here. In triangle PSR, PB is equal to BS and SC is equal to CR. Go and check it again. PB is equal to BS and CR is SC there. Okay, SC is equal to CR. And therefore BC is parallel to PR. Therefore, so we can say therefore BC is parallel to PR. And there we've got it there. So, and therefore we can then conclude that AD is parallel to BC. That AD is parallel to BC. So look at that. Therefore we can say that ABCD is a palm, and the reason being the opposite sides are parallel there. So that's the midpoint theorem in action.